derivative. Okay. Is that okay? Okay, so the first blue one is if we only consider the one dimension only on the x. And the second blue one is we consider the k is the constant, so we take it out. Okay, so this is in the cube, so it's xy coordinate. So today we are going to expand a little bit before we run the experiment. So if we consider a cylinder like this, then we only consider along the axis, 考虑它的径向. Okay, so let's roll it like this. Then assume we have the heat going to transfer out of the cylinder. So assume there's a layer inside. Okay, let's draw it like this. There's a layer. So there's a thickness. This actually is what we are exactly the same in the cubit. Then the r direction is in this direction. Okay. And if we put it slightly bigger here, let's do it like this. The layer looks like this. So the heat is going to conduct from inside to outside. Okay, so this will be QR, this will be QR plus delta R. Okay, this is similar with the one we draw on Friday. We have a cubit and the heat transferred across the cubit. So it will be Qx and become Qx plus the Q delta x. So this is the same in the cylinder situation. So we take the first law again, then the QR minus the QR delta R plus the heat is going to generate will equal to how the system internal energy going to change along the time. Okay, this is the same one. And don't forget, the heat generation is volumetric phenomena. So the Q generation, we can write it down like this, sorry, times the area times delta R. So this is the area. Okay, so later on we're going to play a little bit of the math, so no reason, just want to modify or rearrangement the equation. So we divide our first equation with the area and the delta R, so you can see, then we'll put the minus in the front, then it will be easier to put the Q delta R to the front, and QR delta R, then this will become Q generation and low C T delta T minus delta T. Okay, so if you happen to miss why the delta U delta T will become the low C and times the time difference. I record this a little bit, so this will become low C A delta R C, oh sorry, low A delta R, because this is N and C, and this is what I wrote, delta C. Okay. Okay, so now we push the stuff into the limit. So for example, the time difference is very small, approaching to 0. And also the thickness of the ring inside of the cylinder is very small, so the delta is also approaching to 0. Then the old equation will become minus A and partial, now it's partial. Partial R plus Q generation equals to low C partial T partial T. Okay, those are from the calculus, okay? It is the concept of the limit. Okay, we take another page. Oops. Okay. Then if you recall the Fourier law, the Q equals to minus Ka partial T partial R. Then we can put this inside. So the equation will become like this. Okay, and similar to the XYZ coordinate, then we consider the K equals to constant. Then we can take it out the K. And as you can see here, we have area here. Could you just delete it? No, because the area has the function of R. So if I take it like this, so in the cylinder case, then the area equals to 2 pi r L, the length of the cylinder, right? So the A consists the component of the R, and the equation have the relevant to the partial R, so we cannot take out the R, so we'll leave the R inside of the equation. So the equation will become R then we divide the K to make the equation more concise compared with the one we read on the textbook, and then also put the alpha inside to our equation. Okay? 好，因为 A 里面有 R 的成分，所以我们在我们的偏微分里面有 R 的话，我们不能直接就把 area 直接消掉，所以你可以把2拍 L 的地方消掉，但是你要把 R 留着，好，所以你的 equation 就变成现在这个样子，好，把 R 留在里面。Okay, so this is the case of the cylinder. So what is the case in the spherical? 球形坐标。Then the area become 4 pi r squared. Then you put it into the equation as well. So it will become Okay, you might find there's a chance there. So you will see if I increase the dimension, there's only some of the position of the equation is going to change. And we can remind you guys a little bit about the custom coordinate, the XY system, like we just did at the very beginning of the class. Okay, so this is x, y, z coordinate, and then we only consider the one x. Then if you found you substitute the x into the r, then you will find the relationship. Then you can write it down as the governing equation. The order of the r placed into the bottom. Okay, so this will be the general equation going to solve across different dimensions. Okay, so if it's x, y, z system, custom coordinate, then the n will become 0. Then you need to put either x, y, or z. So it's not going to be r, then you put it to x, y, z. But if n equal to 1, there will be cylinder coordinate. Then if it's spherical coordinate, then the n equal to 2. So only one equation, and then sum up everything. But by looking at this equation, you can find this is a PDE, right? So you already learned with the fluid dynamics, so you know the PDE is not easy to solve by hand. You can probably use the MATLAB or something. So only several cases you can solve the PDE. So with boundary condition, with the initial condition. So this Friday we are going to talk about if we include different boundary condition and different initial condition. Then we can solve this heat equation. Okay. So far we already introduced the complete form of the heat transfer equation. Okay, if there's no further objection, I'm going to switch to our design and group discussion. Okay, let's see if I can switch it. No? Should I project again? Do it again. Number 8. Okay. So now you can see all the equipment in the middle of the classroom. So now you need to work with your classmate and use the screen and design one experiment to prove the water is a poor heat conductor. Once again, listen carefully. To prove the water is poor conductor. 设计一个实验，用现在荧幕上面的所有的东西去做一个实验，去证明说水是一个不良的热导体的实验应该要怎么做。那 so far we have a fire extinguisher, and we have the glass tube, we have eyes, we have goggle, we have fire, and several wire and coins, and of course the holder to hold the tube properly. And we have a thermocouple we demonstrated last Friday. then those are the equipment we have. Then of course, if you want to use your imagination, like the things in your pocket, then you can apply. We're welcome for that. So then we will have 10 minutes discussion, or 10 to 15 minute discussion. Then we will choose one of the group, or two of the group to demonstrate their design in the middle of the classroom, and there will be another bonus point for that group. Okay, so TA, should we switch to the screen to the one they can draw by themselves? And if you don't know how to use it, there's a tab. You can gently tap it and give your screen. No. How can I do that? Okay. Whiteboard. Then now you can try to draw your design on it. So that will be a discussion either in Mandarin or English. Yeah. So 15 minutes. Start from now. 好，用老师提供的这些材料，或者是你现在手边有，你等一下就可以 demo 的方式，去做一个实验，证明水是热的不良导体。Maybe start from think about different ways how the heat going to transfer. There's 3 different ways, and then but now you need to prove the water is for conductor. Then you probably need to emphasize other way to do the heat transfer, right? 好，热的传递的方式有很多种嘛。那我现在要证明水是它的不良导体，所以那可能我需要加强其他种它的其他的热传的方式，然后去证明这件事情。Just remind you guys, every group discussion have a rubric test sheet, so you need to verify the point between you and your lab mate or your classmate. So yeah, 我们会有同台互评，所以请大家就是投入一点哦。这里水不良证明。如果那个电器看能开线，然后再找这个。We look at the whole organization last year. 我要水的热导率和热性Well, I think it depends on the temperature and the
证明水是不良导体，那我们把加热的部分烧掉，不要让它对流。所以我们只要把中央实验器来收走，别的就不能做这里。 它上面插一个，下面插一个。
好，陈总理，
不是啊，不是就这样吗？你从下面烧到对流，还从上面烧到不会对流啊？
好，副总理开始。
你讲完了，那我们这个要做。
是啊。副总理快做。
好，快啊！我想做你这样意思。他这是干嘛用？6块魔术啊！6块。啊，我们点转再按，对，转再按。
So we do have water and we also have ice cube, okay? There's the two material there, okay? We have water and ice cube. There's an ice cube in the thermal cup.
可以加饮料吗？
And you need to use the thermal couple to prove your experiment can work, okay?
你先做实验，这个直接烧吗
No.
我们前置声波刚好都直接烧。
另外你要把钱放在杯子底下，然后加水，钱就不见了。继续讲干，操你妈的！要厕所那个。然后比较跟他比啊。哦。他说我们要烧这个钱，不是我们要怎么拿？你要把钱烧50块，你拿我烧。
我一想到就是我们看加了盐味，
你用抹布包着。
没有，你手要装在这里面，所以你桶要装在这里面。有道理吧？
对，
你懂。今天是水要多，我这个压力跟桶没有，看拿出来就算了。可以啊，我帮你拿出来。对，然后然后加料，这样玻璃不会剥掉吗？试管就是把你干。不是，他说不能直接烧，可以啊，不能直接烧什么烤啦，靠标，来，我知道，基本温度，靠标，它这个差异了，我觉得按一点，是吧？然后下要这个，你把它翻过来了，哦哟。是啊，只是如果水要从上面烧，我们要从上面烧。水要在太累啊，太危险了。我们要开始做。水如果要从上面烧，我们把它倒满，只是桶没办法倒满。没有，你就倒一样深度就好了。但是我要怎么从这里烧？从这里烧，靠标啊！从下面烧呗。妈的，等就你这样烧水，从下面烧就跟你说会对流呗，它不会侧着。对，很快啊，对，很快。试管在你加热的时候，我们要卸的这样。我真的，真的。哦。你做，没有做，你做，烧，这样是跟你放不一样。按水的厚度要这样。对啊。你那是好派头，才发现这个氛围是拿手压的。我把你要对面烧的，直接烧。
Just to remind you, we have water, we have ice cube, we have fire, and yeah, thermocouple. Probably those are the things you're going to use. Okay, so you learn the conduction, convection, and radiation.
对吗？叫，我开始了。
No. We need to present first, and then once everyone chooses you guys, then you are able to go on the stage to demonstrate. So you need to convince everyone first, okay? So draw your figure, and then everyone knows, and then what you're going to convince everyone. Okay? We are going to project your design to everyone.
用一套。对，
要点给我之前，要用那个假套睡觉，我们要开始。
哎，错了，刚刚还是假的，还是一梗，靠腰。
不要帮我换颜色啊！不要帮我换颜色啊！我们要画立体。